Longest palindrome. A palindrome is a word that reads the same backwards and forwards. For example, radar. Right? If you read it forward, it's R-A-D-A-R. If you read it backwards, it's R-A-D-A-R, radar. Complete the supplied function so that it outputs the longest palindromic word in the supplied sentence. So for example, if we give it this sentence, the race car sat level on the track. What the program should do is go through each word. First of all, it should assess, is this word a palindrome? And then, if it is it the longest palindrome? Well, in this sentence, there are actually two palindromes. Race car, R-A-C-E-C-A-R. Backwards, R-A-C-E-C-A-R. Race car, forwards and backwards. The second is level, L-E-V-E-L. Backwards, it's L-E-V-E-L, level. But race car is made up of 7 letters, whereas level is made up of 5 letters. So actually the length of the word race car is greater than the length of the palindrome level. So when we're looking at the longest palindrome, the output should be race car. And that's what we should get. Some constraints. Test input provided will only include letters. There will be no punctuation or other character symbols. Notice that the sentence, for example, has no full stop at the end. In fact, it doesn't have any punctuation, any characters. The only input we're going to get is letters. And there will always be only one longest palindrome. That means they would not, for example, give us another palindrome in the sentence that has 7 letters. There is only one with this longest palindrome, one with the greatest length. As before, they've provided some skeleton code that we're not going to change, but we're just going to move this down to make some space for our work. So we have this function, find longest palindrome, and it's going to return the longest palindrome. In this example input, that's going to be race car. And then we execute the function here with the example input. Now, looking at a sentence and going through every word to check something is actually something that we've already done just before in one of the questions. So try and remember, how did we take a sentence, break it up into words, and then check each word on its own? Try and remember. Well, let's create a variable for this first of all. Let's call it words. So I want to set words to be these individual words stored as separate elements. Well, what we did was we went into lists last time and we used this function that allowed us to create a list from a piece of text. So it took something like the race car sat level on the track, and then it broke it up into individual elements. And it did that. Well, first, the text that we need is sentence. So we're going to go to our variables, find sentence, and put it in here. And we put the delimiter, which is what is separating these words in the sentence. Well, it's just a single space. And now words is going to be a list made up of the, then race car, then sat, level, on, the, and track, all as separate elements in the list. Now, it's common practice in programming, and we've seen it in previous questions, where, for example, if we're counting something, we say at the beginning of the program, the count is 0. And then as I go along in the program, I'm going to increase that count by 1. We're going to do something similar here, which is at the very beginning of the program, we're going to say that the longest palindrome, this thing that we should be returning at the end, is actually just an empty string. So this empty string is the longest palindrome we have. And then every time we get a new palindrome, we're going to compare it to this one and check, does it have a greater length? Is it longer than the existing one? If it is, then let's make this new thing our longest palindrome. So what we want to do is we want to actually go through each word. How did we do that last time? Well, we had a specific loop that goes through a list. So for each item, which we're calling I, in the list words, so I'm going to go to variables, find words. For each item I in the list words, I need to check, first of all, if it's longer than my longest palindrome, and then check if it is actually a palindrome. Well, I need to check two things, and both I said if it has a greater length and if it is a palindrome. So that means I'm going to use an if statement. Now, since we're checking two different conditions, and I need both of them to be true, I can do this in two separate ways. I can say if the length, so let's check. We want it to be length of this word is greater than the length of the longest palindrome. So we need the greater than sign. That was in logic. And we're going to choose the greater than sign. The length of a text is going to be in text. So we can find it here. You choose length of, and then you put the text you want. Now we don't want to write out any text. We want to use a variable because we're comparing the length of I with the length of the longest palindrome. So the first thing we're checking is if the length of this word is longer than the length of the longest palindrome. Because if it's not even longer, why should we check if it is a palindrome? It doesn't matter if it's a palindrome or not. It's not longer than the longest palindrome. So there's no point checking. So we want to check if two things are true. This and something else. So we want to check if the length of I is greater than the length of the longest palindrome, and we want to check if it is actually a palindrome. To do this, it's going to be too complicated to do this in here or even inside this function. So what we're going to do for this question is we're going to create our own function. So far, we've used only functions that they've kind of given us the skeleton for. For this question, let's create our own function. We're going to go to the Functions tab, and we choose which one we want to do. This is for running a function. So just like here, for example, it's doing find longest palindrome. It's executing it. We don't want to run it yet. We want to create the function. And we want it to return a value. So we want a function to say, let's call it check palindrome. So it takes a word and it returns whether this word is a palindrome or not. Well, to add an input to the function, like here, the input is sentence, what do? Of course, if we want to change any block, and it has a blue wheel, we're going to go there and check. And in fact, this is where you add inputs. So we want an input name. Let's check the palindrome of a word. That's going to be my input. Now, we'll get to this in a second, but essentially now I've created kind of the skeleton code for it. And here I can say, if the length of I is greater than the length of the longest palindrome, and I can now, run the function with the word, in this case, my word is I. Well, the way I'm going to write out the function is it will return true or false. So in the logic tab, we actually have true and false values. So it'll return true if the word is a palindrome and false if it's not. So here, I'm going to be checking. If we check the palindrome with the word I, and that turns out to be true, well, that means the word is a palindrome, and I'm going to need to set this to the longest palindrome. Let's just summarize where we're up to so far, because we've done quite a few things, actually. We have our main function, which is to find the longest palindrome. The first thing we did was we created a list called words from the text that we got as input. This is something we've done before. We take the text, we split it up into individual words and store those as elements in a list. Then I start off by saying the longest palindrome is just the empty string, the empty piece of text. Then I go through each word in this list. So first I is going to be the, then I is going to be race car, then I is going to be sat, and so on. Every time it's going to check two things, and both of them must be true. It's going to check if the word I is longer than what I've currently stored as my longest palindrome, and it's going to check whether the word is actually a palindrome. And we're going to do this here in a separate function to just make our code look neater. Separate different functions, different things that we want to do into different blocks of code. So if this word from the list is actually longer than the longest palindrome, and it is a palindrome, well, then that should be my longest palindrome. So I'm going to set the longest palindrome to be this word I. Again, the only way I can get to this block of code is if both this and this are true. If the word is longer than my current longest palindrome, and if it is actually a palindrome. That's why it's longest palindrome, right? It needs two things for it to be the longest palindrome. It needs to be the longest of the palindromes, and it needs to be a palindrome. Right. So we're pretty much done with this part, but now we need to think about how we check whether a given word is a palindrome. Well, let's think about it. If I'm looking at a word like race car, essentially, if you kind of think of the E as a mirror, then it should reflect the first half of the word exactly into the second half. Meaning, the first letter is the same as the last letter. The second letter is the same as the second to last. The third is the same as the third from the last. The fourth is the same as the fourth from the last. And then it needs to stop there. Because there's no point checking, going the other way whether C is the same as C, because we've already done that. So when we're doing this, we're basically checking two things. We're checking from the left and from the right whether two things are the same. So let's create variables to indicate kind of the left and right position that we're checking. So we need two variables. We need a left position and a right position. Well, when we start checking, the left position should be the first letter. So we're going to set it to 1. The right position is going to be the last letter. Well, how do we know what the position of the last letter is? Because, for example, if I'm looking at sat, the last letter is the third letter. If I'm looking at level, the last letter is the fifth letter. If I'm looking at on, the last letter is the second letter. So actually the last letter depends on the length of the word. In race car, the last R is the seventh letter. It's the last, and the word has 7 letters. So actually the right position is just going to be equal to the length of the word. In sat, because it's a 3-letter word, the last letter is the third letter. So we're going to use length of again, and this is going to be the length of the word. This is the input to our check palindrome function. And we said we're going to keep track of whether it's a palindrome or not by, returning true or false. Well, one way to do this is, before checking the letters, assume it is a palindrome. So let's say it is. So it's true. And then we check the first letter with the last letter. Are they equal? Cool, that's fine. We carry on. As soon as we find a pair that don't match, so in race car, we won't do that. But in other words, as soon as we find a pair that don't match, for example in sat, if I check the first and the last letter, S is not equal to T. It's a different letter. So I'm going to change it to false. No, it's not a palindrome. As soon as I find a pair that's where the letters are not the same, I'm going to say, no, it's not a palindrome. Otherwise, I'm just going to keep checking until either I get to a point where these indicators, these positions that I am using, meet up, just like here we said at letter E, they coincide. The position, the indicator that was coming from the right and the one that was coming from the left collide here, and that should stop because there's no point checking in the other direction. So I'm going to create a variable called is palindrome. And as we said, we're kind of giving it the benefit of the doubt at first. We're saying at the very beginning, let's assume it is a palindrome. And only when we find a pair of letters that don't match up do we change this to false. So we set is palindrome to true. Now, what we're going to need to do is write some kind of loop that, keeps moving the left position to the right, one letter at a time, and the right position to the left, one letter at a time, and checks the pairs. So let's think about what's going to happen inside the loop first. We're checking if I'm checking if two things are equal, two letters are the same. Well, how do I use the position of a letter, this index, to find the specific letter in the text? Let's check the text tab. You see here, we have this block that says in a given text, get letter number something. So I want to check if in the text word, oh no, sorry, we picked the wrong block. We want this one. If in the text word, letter number, well, the letter at the left position is equal to that at, let's put this here for now, is equal to that at the right position, that means they match up. So actually, it's quite good at this point. But what we want to do, remember, we said we're going to check this with this. We're going to check this with this. What we're trying to find is not a matchup. We want to find a pair that doesn't match up so that we can change this to false. So actually, if I find a letter on the left position that's not equal to a letter at the right position, then I'm going to set is palindrome to false. Let's just make some space for this, because I still don't want to add it, because this is going to be repeated. Because every time I check, as I said, I'm going to need to move my left position to the right and change my right position to the left. So that means I'm going to change my left position by 1, and I'm going to change my right position. Try and think about it. If it's going to the left, if it's starting with the length of the letter, so starting at 7 here, I want it to move to 6. What am I doing? Well, I'm changing it by -1. I'm moving it to the left. And I want to keep repeating this until the right position and the left position collide, or until they meet. So here we're going to use a loop that we haven't used in any of the questions we saw before. It's a while loop. A while loop repeats while some condition is true. So in this case, I want this to keep repeating as long as the right position and the left position have still not met. So while the right position, or let's do, while the left position is still less than or equal to the right position. And this is going to go in my function. And in the end, what I return is this variable, which holds either true if the word turns out to be a palindrome, or false if it turns out that it's not. Now, let's just do a quick summary of this function because we did quite a lot of things. And I'm going to use two words as examples. I'm going to use race car and track. So let's say we get to this point in this function. It's going through each word and it gets to race car. So I is race car, and it's checking here if length of I is greater than the length of longest palindrome, and check palindrome I is true. So now it's calling this function. So the word given as input to the function is race car. Left position is 1, right position is length of word. Word is race car, so its length is 7. So left position is 1, right position is 7. And we're saying, as far as we know for now, it is a palindrome. Now, it keeps repeating while left position is less than or equal to right position. Currently, left position is 1, right position is 7. It checks 1 less than or equal to 7. That's true, so it's going to run what's inside the loop. If the letter number 1 in this word is not equal to letter number 7, then this is not a palindrome. Letter number 1 and letter number 7. Actually, they're equal, so we're not going to change this. It's not going to get to this point. What's going to happen is we're going to increase the left position by 1 and decrease the right position by 1. So now left position is 2, right position is 6. And it checks, is left position less than or equal to right position? Is 2 less than or equal to 6? Yes, it is. So it's going to run what's inside the function. If the second letter is not equal to the sixth letter, is palindrome is false. Well, the second letter is equal to the sixth letter. So it's not going to change this to false, but it's going to move the left position by 1, right position by -1. So now 3 and 5. It checks here first to know if it's going to run the loop. Is 3 less than or equal to 5? Yes, it is. So it's going to run the loop. If the third letter is not equal to the fifth letter, change is palindrome to false. Well, the third letter is equal to the fifth letter. They're both C. So actually, it's not going to do this. is going to change the left position by 1 and the right position by -1. So now the left position is 4 and the right position is 4. It checks here. Is left position less than or equal to right position? Is 4 less than or equal to 4? But it's equal, so this is going to be true. It checks if the fourth letter is not equal to the fourth letter. I mean, they're exactly the same letter, so they have to be equal. It's not going to change this to false. Now it changes the left position by 1, the right position by -1. And so the left position is now 5 and the right position is 3. Is 3 less than, no, left position is 5, right position is 3. Is 5 less than or equal to 3? Well, no, it's not. So this condition is false, so it stops running the loop and it returns is palindrome, which, since we never actually got to this block, is true because we set it to true in the beginning. So it basically tells us here that race car is a palindrome. Now, if we do the same thing with the word track, it does the same. So it says left position is 1, right position is the length of the word. So right position is 1, 2, 3, 4, 5. And it repeats, while left position is less than or equal to right position. Is 1 less than or equal to 5? Yes, it is. So it's going to run the loop. If the first letter is not equal to the fifth letter, is palindrome should be changed to false. The first letter is a T, the fifth letter is a K. So actually, this is true. They are not equal. So it changes is palindrome to false. And it keeps checking other pairs, but because we've changed to false and there's nothing after it that could possibly change it to a true value, then when it returns is palindrome, here it's going to return false. And in this case, this part is going to be false. So we don't get to this block. And so track isn't even considered to be longest palindrome because it's not even a palindrome. And if we try that, we get race car is the longest palindrome in this example input. Cool. So we have done all the questions. You have seen that actually the first few are somewhat simpler than the last two. And that's why they count towards only half the marks. So make sure you use your time correctly as you go through these questions. Remember, always read the information. Sometimes it's just a nice reminder to hide the menu to give you more space. Sometimes it does include quite a lot of important information, such as with, where did we see it? Here, for example, it gave us information about the faded versions, the colors of the shapes, and the thickness and the measurements that we're going to need in our shapes. So do make sure you check this information. Remember, for the questions like this, when they give us some code, we shouldn't alter it. Leave it as it is. You can move it around to create more space for you to write code or to add blocks, but do not change any of the measurements, do not change any of it, except if, they told you in the question, like they did in Hilbert Hiccup, that one of the numbers is wrong. So there's a single numerical error, and that's what we had to do. We had to find this numerical error and change it. Perfect. I hope you found this useful, and I wish you the best of luck with completing the UK Bebras Coding Challenge. Thank you.